What is the most important thing a person does in his life? That's decision making. And one of the most inevitable challenges in decision making is uncertainty. The whole field of data science is to measure and control for this uncertainty, to optimize, to maximize, or to minimize. It is this uncertainty that distinguishes mathematical models from statistical models. Mathematical models are deterministic in nature, whereas in reality, often we need to deal with stochastic elements. You can visit our discussion on a complete understanding of data science in less than 1 hour to understand in more detail about what is the difference between statistical models and mathematical models. Uncertainty could arise due to a number of factors. It could be because you do not have enough information, or maybe you are measuring something where there's a measurement error. It could also be because of the randomness of human behavior. Now, the typical cycle of data mining is you start off with some input data and you do some pre-processing on that data because data in its raw format might not be really useful. You need to clean up the data in various ways to be able to mine that data. And that part of cleansing and processing and finding out interesting patterns is data mining. Once you have mined the data properly, you have to do certain post-processing stuff. And after you complete your post-processing, you gather information and knowledge out of it. One of the key ingredients of successful data mining is having substantial prior knowledge about the data and the business processes that are generating this data, which is known as subject matter expertise. Now, the art of data mining combines the knowledge of statistics, subject matter expertise, knowledge about database technologies, machine learning techniques, and so many other things in order to extract meaningful and useful information from the data. There are broad types of data mining, and the two broad types are predictive and descriptive. Predictive modeling is where you try to predict something. For example, you could try to predict if it would rain tomorrow or not. You could try to predict what would be the sales in the following quarter for a particular company ABC. Descriptive type of data mining mostly deals with finding out inherent and implicit patterns within the dataset. Often data mining is also done through what we call as association analysis. What association analysis does is it tries to find out interesting patterns from within the data, which would help us understand if two things or 2 points or two series of data are related to each other or associated with each other or not. There's one other kind of data mining also known as anomaly detection. For example, if you were to look at cases where you are trying to find out if there has been a fraudulent activity in a transaction at a bank or not, you could look at it from an anomaly detection point of view. There are multiple algorithms for you to look at while doing data mining. And an algorithm is nothing but a logical step-by-step procedure for solving a problem. It's more like a blueprint for how a particular data problem needs to be solved. Most of the algorithms that you would find are generally recursive in nature, where there are a set of steps which have to be repeated in a number of times until some condition that you set is being met. There are also algorithms which deal with random variables as inputs, and they are known as randomized algorithms. So one of the very core definitions or core term in data mining is that of CRISP, or known as cross-industry process of data mining. In short, data mining, or also known as KDD, which is knowledge discovered from data, is an approach to find patterns from the data. Now, CRISP DM is an industry standard and an ideal framework to follow while you do any data mining process. One of the most popular data mining process frameworks is CRISP DM. This framework was developed by a consortium of many companies, who were involved with the task of data mining. And it's one of the most widely adopted framework for development of data mining solutions across the globe. There are other data mining frameworks as well, such as SEMMA, which is for an abbreviation for Sample, Explore, Modify, Model, and Assess, which had been developed in 2013 by the SAS Institute. There's also another data mining framework called DMAIC, or DMAIC, and this is widely used, or you would be familiar with this term if you have dealt with Six Sigma processes. What DMAIC stands for is define, measure, analyze, improve, and control. So similarly, there are many such data mining frameworks, but the most popular one is the CRISP framework. Now, there are a few important terms that one needs to be aware of while understanding this whole process of data mining. When we talk about prior knowledge, what we are saying is it refers to the information that we already know about a task or a problem that we are trying to solve. Data mining is not a practice or a problem solution approach in isolation. It has to always be coupled with subject matter expertise, contextual information, and other aspects. The prior knowledge step in this data mining task helps us to define what is the exact problem that we are trying to solve, how it really fits into the context of the problem that we are trying to solve, and what is the real data that is required to solve this problem. All it does is it tries to find out hidden patterns from within the data by trying to establish and identify the relationships between different variables, factors, attributes, and all of those things. But often, a data mining task might result in uncovering a lot of patterns, and a lot of patterns which often do not make a lot of sense. There could be false signals that you come up with. There could be a lot of noise in the patterns that you see from the data. Now, it is up to the data mining practitioner to filter out those patterns and pick up the ones that are really valid and relevant to the particular business problem that you're trying to solve. Therefore, it is extremely essential to know the subject matter, the context, and what is the underlying business process that is generating this data. How the data is being collected is also a very important factor while doing data mining. Understanding of the data collection method, the way the data is being stored or transformed or being reported, is extremely important in an overall data mining process. This part of the step considers all the data available to answer the business question, and if needed, what data needs to be sourced from which particular data source. You have to consider a lot of factors while dealing with data. The quality of the data, what is the amount of data you are looking at, is it available all the time, how much accessible is the data, what happens when the data is not available at a given point of time. Does lack of data compel the practitioner to change the business question, etc.? Now, the objective of this particular step on data understanding is to come up with a data set from which you could really answer all the business questions that you are looking at. The model, the statistical model or data model that you would build is, would be as good as the quality of the data that you would feed into it. So there's this popular term called GIGO, which refers to garbage in and garbage out. A data set is nothing but a collection of data with some particular defined structure to it, and the data point is one single instance of this data set. An attribute, which is often also known as a feature or an input or a variable, a predictor, a dimension, however, whichever angle you look at it from, is one single property of a data set. And the label is an output or a target or a response variable that needs to be predicted based on these attributes. For example, common attributes would be things like name of a customer, account number of a customer, employee ID. These are all identifier attributes. These generally do not bear a lot of information, in itself, but these might help while reporting out patterns. So, business understanding and data understanding form the two most important pillars of this entire data mining process. Now, the next task is to prepare this data. Preparing the dataset to suit a data mining task is one of the most time-consuming parts of the entire data mining process. Very rarely, data is made available in the form required by the algorithms that you would use. Most of the data mining algorithms would require the data to be structured in a particular format, mostly in a tabular format with your records in rows and attributes in columns. Now, if the data is in any other format, then the first step that you need to do is to generally transform the data by applying, either a pivot or a transpose. For example, the condition, is you have a condition where the data is completely unstructured and not formatted at all. So you need to transform the data into the required structure to be able to feed it into the algorithm that you're looking at. You have to look at missing values. You have to look at things like outliers. So data exploration is a very important step in this entire data mining process and takes up almost about 80% of the entire time of this entire task. This often also known as EDA or exploratory data analysis is uh, sorry about that. So basically EDA is a framework which provides with a lot of simple tools to achieve a basic understanding of your data. And it could involve a lot of things like computing descriptive statistics or looking at certain visuals of the data to be, and from there you could arrive at a lot of insights and patterns out of the data. You have to understand about what the data quality is. If there are, duplicates, you have to remove duplicates. If there are outliers, then maybe you need to cap outliers. You could maybe also have to standardize attributes, and there are, detailed discussions about standardization, how to do duplicate removal, or how to treat outliers, how to treat missing values, all of those things. Now, regardless of all of these things, it is critical to check the data using data exploration techniques in addition to prior knowledge of the data and business before building out any model. You might also need to do things like data type conversions. wherein you might need to convert a categorical attribute to a numerical or vice versa. So, for example, you could encode a specific numerical score for each category. For example, if you're looking at poor, you could numerically code poor to something like 400. You could code, code something like maybe good to maybe 600 and excellent as 800. So if you have a distribution of marks in an exam which have been labeled as poor, good, and excellent, you could numerically codify them. So this would require data type conversion from character to numeric. Similarly, you could also have uh, numerical values like 600, 400, and 800, and you might have wanted to look at categories which combine these numerical values into some groups. So in that case, you could have done something like a technique called binning, where you could say if marks is 200 to 400, then I call it as group 1. If it is from 401 to 600, we call it group 2. Similarly, you could also transform variables. Often it is useful to transform variables for a lot of reasons. You have concepts of uh, standardization or normalization. Often the deal here is that if you're looking at variables which are not on the same scale and you're trying to build a model, then definitely what happens is your variable which is at a higher scale might dominate your model. And you might not want that really to happen. So that is why often you need to standardize your data before even developing a model. Transformation could also find its use when you have things like, for example, you are looking at sales. This is your sales dollars, and you are looking at television advertisements today. So often you need to understand, how your television advertisement really impacts the sales dollars. So this kind of an understanding is what is getting covered in subject matter expertise, right? And unless you know what is the exact way in which your television advertisements really affect sales, you would not know what kind of a transformation maybe you need to apply on this particular TV advertisement variable so that it's able to capture the dollar sales, pattern from the data. Now, the next step is once you have done this exploratory data analysis, is to develop your model. Now, a model can be simply thought of as an equation or set of equations which help establish a particular relationship between two data points. You could imagine this to be of the format y as a function of x, where you could think of y as a vector of observations and x as a vector of factors. Imagine y as your sales and x as a vector of all factors. So what are the different factors that could impact sales? It could be things like holiday season. It could be things like advertisement spend. It could depend on a lot of macroeconomic factors like unemployment and many such things. So once you form this equation, you are all set to build your model. Now there are two critical steps while developing your model. One is that is called as train, where all you are doing is you are feeding your model with relevant examples and training your data on these examples to generate some output which is represented as y hat. So y hat is nothing but the predicted outcome of building this model or this relationship between y and x. Now, once you train your model, the next task is to test how good your model is And for this, all you need to do is you have to use the same model that you have finalized based on the first step and feed that particular model some new unseen data. And once you feed your unseen data to the same model, you would get some results which might be y hat dash. So the overall objective of model development is to build a model which is robust, or a model that can be generalized to the population. Now, to understand more about what training is, what test is, and what the entire process of model development is, you definitely need to visit our other videos and stay tuned to our channel to understand these topics in much more detail. Now, the other step once you are done with your model is to look at model evaluation. We covered this in some bit over here. Now, what model evaluation really talks about is, okay, now you have built a model, but how good is your model? Is your model just good with the data that you have trained it on, or can it really identify patterns in a good way if it is being fed new data, which is absolutely unseen at this particular point of time? So often what happens is you could build a model where, suppose, this is your data and you have built your model which is almost trying to mimic the pattern of your data, actual data. So in this case, what happens is what we call as overfitting model, overfitting in your model, which means that it captures the patterns in your training data so well that it gives you an accuracy of almost close to 100%. Now that's a good situation, many might think, but there's a hidden problem with that. This kind of a model is very much prone to being non-robust. So what happens is once you feed it maybe a new type of data in the test condition, it might not be able to generalize the model well. It might still, do things like this. It might fit the model really bad. So this is the condition where your model is told to be overfit. And this is definitely not a good thing. So you need to always be vigilant about the fact that the model that you have built, no matter how good it is on your training data and how accurate it looks like in terms of R square, it might not be really robust. So this is a very important step in the data mining process. Now, the next uh, step in this entire crisp DM methodology is once you have now built your model, once you have decided that this is your final model that you have built, and your model is good to be, productionalized, then all you need to do is deploy this model. So deploying a model means making this ready for production. So the next step here is that you have built your model and all you now need to do is send your model to the respective team or even by yourself to an environment where it is ready for use. Now your model can be used by policymakers or people who devise different strategies, different marketing strategies and marketing policies, who need to take care of what is the advertising budget that they should maybe, lay down on things like TV or radio or magazine. What is that amount of investment that they should have in all of these things? They would now use your model for production. The end goal of this entire data mining process is you start off with prior knowledge and you end up with posterior knowledge. So this is the incremental insight that is coming out of this entire process of data mining. As with any quantitative analysis, the data mining process can point out any kind of spurious or irrelevant patterns from the dataset. Not all of the discovered patterns that you see leads to knowledge. Again, it is up to the practitioner to invalidate the irrelevant patterns that comes out of the data and only pick up the meaningful information. The impact of the information that you find from data mining can be measured in an application. So that was all for this particular video on basics of data mining, and I hope that you have learned something new. You have seen what CRISP DM methodology really talks about. You know the various steps in this entire methodology, and to go deeper into each of these, I would encourage you to stay tuned to this channel. Follow this channel. If you like this video, click on the like button, and if you want to stay updated about all the video notifications and whatever sessions that we come up with, I would suggest you to hit on the subscribe button and even click on the bell icon to stay notified about any of our new updates. And hope you guys have a great day. Thank you for watching. If you need any help, look at the comment section below, and over there we have provided links to all our earlier videos and certain other details that you might really find very useful. Thank you for watching.